We're delighted to have you. NASA's been very busy lately. They're again looking beyond Earth orbit to the moon, Mars, and faraway orbs, once only imagined in science fiction. Our speaker is a project manager at NASA Ames Research Center, having led ESD program and co-investigator of SOAR-X 10 in safety mission and assurance for Tech Ed series as the only federal employee and person of color. She is the go-to person at Ames for questions related to the International Space Station, safety and design practices for small satellites and technology development. So let's have an outer cosmos welcome for Ali Guarneros-Luna.
Hello. How you guys doing today?
We're good.
Okay, so I am going to try to put my presentation up. There you go. You guys are seeing it, right?
Yes.
Okay. Let me put my slides. Okay. So as you guys know, my name is Ali Guarneros-Luna. I usually use my personal email right here. And, you know, today I want to talk about some, I'm going to give you a little bit of my history, some of the work that I have done, and perhaps, things that, NASA also is doing, right? So just to give you an idea, well, I'm an aerospace engineer. I graduated from San Jose State. I did my bachelor's and my master's. And when I was about 7 years old, growing up in Mexico, my mother used to buy books from this guy that would come to the house. And so I would come home and I find all these books to read, right? And one of them had the space shuttle, and which I thought it was amazing. At 7 years old, it was something very much out of the world, right? It was going to take humans into space. It was going to put stuff in space. And I thought about it. I learned, I read, and I fell in love with aerospace engineering. So when I was 7 years old, I already knew that I wanted to become an aerospace engineer. So here, when I was at San Jose State and they had the degree, I decided to follow that engineering discipline. And so I graduated with my bachelor's and my master's, and through that process, I was able to get an internship at NASA Ames here. And when I was at that internship, it was supposed to be only for three months, and ended up being extended for a year. And then after a year, I became a contractor. And then at the end of that year, there was an opportunity for me to become an aerospace civil servant. So I applied for the opportunity, and I've been here ever since. And that was back in 2013. So I'm almost 10 years here as a civil servant. And so, the good things, the stuff that I really like about aerospace engineering is that when I was at San Jose State, I had the opportunity to start working in rockets. So here I have one of the rockets that we launched in Nevada. It took us 6 months to build it, and 6 months to design it and 6 months to build it. And with, in the minute you see it going up all the way up, right? And that experience was, very motivated for me because, that's when I started, getting into aerospace, right? And so the one thing that I learned about this experience is that not everything that you plan, it happens, right? So when this rocket was going up, it was supposed to go reaching apogee and then come down, right? So what happened is that the rocket actually tilted, and it was already reaching Mach 1, which is, as far as the speed of sound. And the computer on board thought that it was going to, it was reaching apogee and it was going to come down, right? So the rocket went up, tilted, and then it deployed all the parachutes, and the parachutes broke. They were completely shredded, and the body of the cone and the body completely separated. So the body came ballistically to the ground, and the cone, which I have it right here, I have it right here. I ended up looking at finding it around in these mountains that are like 8 miles away, and it took me 2 weeks to go and get it, but I was able to get it. And obviously the other thing that I did as an as a aerospace engineer in San Jose State, it was robotics. At San Jose State, we have this rover that we were going to take into Antarctica to help the astronauts. I mean, not the astronauts, the scientists in Antarctica, because Antarctica is too cold. They don't get out. They cannot get out because it's so cold, and they only have 3 months to get resupplies and get stuff. Go and get examples and then come back. And so we want to give them a rover so they can, during the months that they couldn't get out, be able to use it to like bring water or examples or take pictures. And that's the rover right there that we, as students redesigned and took it to Antarctica. Anyways, so when I started working here at NASA, one of the things that they put me to start working on, it was the International Space Station. And so, as you can see, and you probably know, it's orbiting the Earth between 300 and 500 kilometers in altitude, right? And it's as big as the football field, so it's huge. And we actually ended up building it in 2013. That was the last module that was attached. And during all that time, we have astronauts. We have, normally we will have 6 astronauts because it takes that much to maintain the space station. Space station is so old. It's about 20 years plus, on some of the modules that are being up there. And so you have to maintain it and constantly, changing things, batteries, the solar panels right here that you guys see, they have these rollers that, they rotate, right? And so sometimes, they get stuck. So the astronauts need to go out there and, change parts or put oil. And so, there's a whole maintenance that needs to happen for the space station. And so we need to have about 6 astronauts to do all the maintenance plus the science, right? We also have the only window that is right here, the cupola, and that's where the astronauts tend to hang out and take pictures of the, of the Earth, absorbing, and especially now that we're having all these fires, and things that are happening in Earth with the hurricanes, stuff like that, they get to take pictures and send it back to us. So a lot of the pictures that we get from space, some of them come from, from the astronauts that are taking those pictures. These right here are 2 different experiments that I work on. Right here is the Soyuz. Just recently, we used to have the Russians take us up to the space station, right? But nowadays we have, we're now doing it, in the American soil. So, and obviously, the space station, the communication system is very complex because as the space station goes around the Earth, they have to have different communications, bandwidth, that they have to talk to, and different ground stations, right? So we have some in United States, some in Japan, some in Russia, and some other places. And we definitely use, some of the satellites, like the TDRS, to when in emergency we have to, talk to it. And we have to have 24 hours communication, right? And I don't know, do you guys have any questions or can I just continue talking? Yeah,
Keep
okay.
going. Keep
We will
going.
have questions.
Okay, so one of the biggest research that we have is the human body, right? Because when the astronauts go up in space, their body changes. They have changes in their body. One of them that I can tell you right away is that when they arrive, they cannot eat solid food. They have to eat liquid for 2 weeks. And the reason is because their stomach has been pushed up, right? There's no gravity. There's nothing to, to have that stone, you know, the liquids in their body actually tend to make us fear, right? And so everything gets pushed, right? And even the stomach. And so they don't get to eat solid for, you know, for 2 weeks. And then also one of the other thing is that they start losing muscle and bone. And so to mitigate that, we start having the astronauts do exercise for 2 hours and also eat food that has enough calcium and vitamin D. The other, you know, transformation that they start having is that their eyes, you know, when we have an oval in our eyes, but when you're in space station, it becomes a sphere. So the light comes in a different way. And, you know, they need to adjust to that. Also their vertigo, you know, the liquid that you have in your ear, you know, it's not, you don't use it when you're in space. So when you come down, they have to readjust. You know, if you guys seen some of the pictures from the Russians or videos, the astronauts, you know, have to be lifted. They don't let them walk. And the reason is because, you know, they don't have that sense of, you know, stability when they arrive, you know, from space. And so it is, you know, the human body still, you know, needs to be explored in that sense. And the one thing is that we can only keep them for about 6 months in the space station. Longer than that, you know, it could be a risk to their body because we don't know how they're going to be able to adjust when they come. And recently we had a study about two twins, you know, and one of them stayed for a whole year. And we are still finding a lot of things about, you know, his changes in the body. He still is trying to recover from it because there were some changes in his body that is taking longer time for him to become quote unquote normal, right? And so, you know, there's all these research that, you know, that we're doing with the human body. Now, I won't tell you that, you know, working for NASA has been amazing. One of the, I can tell you one of the greatest experience I had was actually meeting these two astronauts. They were the last two astronauts that drove the space shuttle, right, before you got retired. So for me, it was like a closing cycle of my life, you know, having that experience of growing up with the space shuttle and being able to, you know, meet these two guys. It was an amazing experience. I also travel a lot because of my work. I have to constantly talk to, you know, scientists and engineers, you know, and present my work. I go to a lot of conferences, and the most rewarding, you know, experience that I have is that I get to work with a lot of young engineers, you know, as you can see in this picture below. And obviously, you know, we're trying to change, you know, the diversity here. As you can see, there's only 3 women and few people of color, but, you know, um, but we're trying to, you know, make it more diverse, right? Now, when I started working for NASA, one of my first work or job was to try to find out a way to start working in the space station. When you work in the space station, you know, the astronauts, it's really hard for them to do things, you know. And one example right here I have is of Samantha Cristofelli. She had to be tied from the feet and hands, right, to be able to work in a biology experiment. And all her instruments had to be typed. As you can see, there's, you know, tape and scissors all, you know, taped down to this platform, right? And everything had to be encapsulated. Because there's no gravity, everything floats, right? And we have a rule that if you're working inside the space station and it moves from your eyesight, it will get lost forever. Usually they tend to go into the holes or underneath things and you just never see it again. And so for them, it's very important. And, you know, there's a lot of process into do any of the work, right? Think about it, you know, how they're going to make anything. And so one of my first project was, you know, to study, you know, different ways of making something that's complex, labor time consuming and intensive to make it simpler, modular, rapid, right? And look at different structures. Right here, I have a picture of one of the plug and play processes of the FRL when they start doing it, you know, looking into this about 15 years ago. And then MIT, they start looking into structures where they can build one or two things of, with the same form factor, but different material, and make something out of it. And so out of these, out of this study or this work, we start talking about digital materials, how do we start making process, that minimize the, the time consuming to assemble something. And the few out of this study, few technologies came out, which is the manufacture, fabrication, and assembly for space. And one of these, obviously you guys see these videos of this CubeSat, which it was the initial study, but I can tell you that after a few years, this study got into the private sector, and we have right here this company that has a module right in the corner next to the module right here, that it was completely collapsed and folded, and it was taken into one of those, I don't know if it was a SpaceX or Boeing who took it up to the space station, so, and then the astronauts disassemble it, went outside and attached it to the module and inflate it. It's actually inflatable structure. And it's been there for about 5 years now. And we're doing studies because we have another structure that is bigger, that is in Houston, Texas. And we want to, put it up in, in space, because as I was telling you at the beginning, the space station is so old that we have to replace it. And it is too expensive to do it. We don't have the space shuttle anymore. So we have to find a ways to be able to take huge modules, huge structures that it can maintain human life in space, and also, be able to do all the stuff that we've been doing. So, that is one out of these, work that I have done, the results, that already been developed. And also the space station, just to give you an idea, has a lot of things that has changed our way of life. One of them, and I think I'm very proud of, is the water recycle, which is right here in the bottom. As you can see, this is actually the unit that is in the space station. And we use it, recycling the, the pee of the astronaut, and also the humidity of the space station. We're able to recycle that water and make it drinkable again. And we gave the patent to a company, and they made it modular enough that they can actually take it to places like in Mexico, South Africa, Utopia, and places where the drinkable water is not possible. And we're starting to change the life of populations where having clear drinkable water is not available there, right? But also there's other things that we have done that they have changed the way of our life. We have developed all these technologies that affects our daily life, and our future, right? And we continue to do it. A lot of the technology that NASA is developing for the space shuttle, we did for the ISS or the Apollo missions, we are all now using it in our homes, in our daily lives, And so these are some examples, of that technology that every year, NASA puts out into the commercialization for the companies to use and make something out of it, right? You guys don't have any questions, right? I keep going? Yes, okay.
I have a question for you, Ali. This is Skip McCowan. You must be an inspiration to a lot of little girls who are looking to become aeronautical engineers like you have, let alone little Hispanic girls. What do you do, if you can, in your spare time to encourage these young kids to enter into this field of work?
Well, I give a lot of talks, and I also do workshops. And I'm very much trying to be able to, I try to make a representation of, of engineer. I'm an engineer, I'm an aerospace engineer. So I'm trying to be out there, be a spokesman for, for this trade and for this work that I do, right? And so I locally here in California, I try to reach out to college, to universities. I'm actually a teacher at San Jose State. I'm teaching a class, and also participate in all different conferences like the Society of Women Engineer, the CHEP, and I try to get involved in my community, because it is very important that, you have somebody that looks like you, right, in the field that you want to get in, and that everything is possible. And in fact, I'm also part of the museum, the computer museum here. I'm in an exhibition, and I've been, part of different, um, different platforms that I can be part, that I can, demonstrate who I am, right? So I'm trying, I'm doing my part. So I don't know if you want me to continue doing that, or, or continue to the presentation.
Ellie, could you go back to that slide of NASA and the household products and just name a few things that we now use that were invented for space?
Well, there's so many things. Okay, so obviously, well, the cars, a lot of the new cars, they're used, to design them, we use CFD, which is computational fluid dynamics. And, before, and if you guys see this little car right here, is, it's not aerodynamic, right? So it was inefficient, it will take us to place, but it was not efficient enough, right? So nowadays, all these companies that are building, cars and even trucks are using computational fluid dynamics, which it was something that we started designing because as we were trying to leave the Earth to go into space, we needed to understand how the flow behaves around, like a rocket, right? So how do the flow behaves and make it more efficient to go through the Earth, right? So, the cars, all the designers, all the companies, they use that to make it aerodynamic, to make it more efficient, so they don't waste a gas, and and just take you faster from one place to another one. The other one that I can tell you, that I know of, if you guys remember, the rockets, going into space, you use, we have, the astronauts have to sit down in the chairs, and the loads of the rockets were really tremendous in the body, because at the beginning, the astronauts, in Apollo and Mercury time, the astronauts, their backbones and muscles used to get hurt. So NASA needed to come up with a solution to absorb the shock and the vibration of the rocket. And so they came out with this material that they put into the chairs. And so when the astronauts sit down, all that vibration, is absorbed by that material. Eventually, we use it now in the mattresses and even shoes, that they have this foam that when you walk, if you have it in your shoe, it actually dampers that, vibration, and it doesn't hurt your knees, right? Or if you have it in your bed, you can actually sleep and take the shape of your body. And, it makes you relax and doesn't, create a strain in some of the parts of your body that might be hurt. We also have, when the astronauts go outside in this, in the space station, they have to use the spacesuit, and they use a specific material to keep the warmth of the body. Nowadays, we use that for babies, when they're prematures, and places where they don't, have an incubator, or for whatever reason cannot get the baby in the incubator, we use that same material to wrap the baby and keep it, warm and healthy, right? The other one that we have is the baby formula. When the astronauts start going into space, they were having this issue of food, right? They don't have a refrigerator, they cannot cook. So we have to make these, meal shakes per se, that they had enough vitamins and nutrients for the astronauts to be able to survive. And eventually they're now using it on baby formula, and also even, for adults, that they're having some, difficulty getting the appropriate nutrients. And one other one is the robotic arm that is in the space station. That whole complex of software and programming to be able to grab something or align something. Now we use it in the hospitals when we're doing operations. A lot of the some of the hospitals are using that same process of software when they're using a robotic arm to operate on people. And I mean, I can keep going and tell you even more. But you know, that's something that, you know, we continue to do. A lot of these you know, innovations that we do for space, they come back to our Earth to solve problems.
Thank you.
Hi, Ali.
Yes.
Could I ask you one, please? Do you lose much water when you're going through the recycle process that you were talking about here?
Not that much. Actually, we're even finding that through the years, because at the beginning we, you know, it was not as much as efficient as, you know, we thought it was. We were, you know, taking water, but as of right now, currently, we have enough water that we can actually maintain 6 astronauts in space for a whole year. So, you know, it's not bad. Yeah.
It's very efficient.
How
See,
about
yes.
space? How about space debris? Is that a problem there that you, how do you avoid getting the space station hit by stuff?
Yes, that is an imminent risk. You know, the space station is constantly, you know, be guarded by, you know, people here you know, in NASA, because, you know, there's definitely a lot of things flying up there. And so what we do is that when we track all different objects that are flying around the space station, and obviously when we think that something is going to be hit the space station, we do several things. One of them is that we try to see if we can maneuver the space station to avoid, you know, the orbit of that object that is coming in the direction, or we push it up to a higher orbit or push it down to a lower, you know, orbit. So, you know, we're trying to, you know, maneuver the, you know, the impact. But if that doesn't work for whatever reason, because it does happen that, you know, sometimes objects come flying and they come in a lot of, you know, speed. The speed is so high that sometimes it doesn't give us enough time to do the analysis of where the trajectory of this object is going to be, or it doesn't give us time to do the maneuvering that we need to do because it takes some time. And so what we tend to do is that we ask the astronauts to turn everything off, go into the module that they came in, lock themselves in, and wait until we can tell them to come out. Because if it hits it, and for whatever reason, you know, it destroys a module, you know, there's no way for us to have it closed down, right? If it's too big. I don't know if you guys recall I want to say a few months ago, we had a projectile that went through the space station, made a hole, and one of the astronauts noticed it, and he immediately put his finger on to make sure that there was no, you know, no pressure difference, so that the structure will not break, right? So that's, you know, those are the things that, you know, happens. And I guess somebody raised their hand. No?
Yes. My
Yeah.
question for the water recycling machine, is that scalable for, say, a building, an office building, where they could completely become internal with all their plumbing use and all of that?
That is a good
deployed?
That is a good question. I mean, as long as it's big and has the same volume of a system that the space station, I think it will be viable, right? Right here, this is the portable one that the company CPK is actually building and using and taking it to different places to bring in, you know, drinkable water. But it's viable.
Thank you.
Question.
Yes.
So we've been seeing these movies, right, called Away and Martian, and right? So so tell us, how feasible is it to go to Mars? And, you know, what is it going to be like? What do you think?
Well, it is very difficult. And actually, let me just go. I have more slices, but here. It is very difficult, right? Uh, Obviously, you know, we went to the moon. You guys probably were alive when this happened. You know, we're able to see it. I was not here yet. But before we arrived to the moon, we actually had to put a lot of money into these resources. If you think about of Apollo missions, you know, when this happened, or the government was giving to NASA in the GDP 5% of the GDP. That means that 5 pennies for every $100 that they got back for their taxes. Right now, we're getting less than 1/2 of a penny for every $100, you know? So we don't have the money to be able to even do the same thing that we did for Apollo. We are relying that we develop all these technologies back in the 60s, and then we can probably use them to be able to go to the moon. But in reality, I mean, even though we want to go and we are going to the moon, it is going to be very difficult. We need to have the infrastructure, you know, the technology to update all the stuff that we have, you know, to be able to do it again, right? And also we know from this, you know, you guys probably know about Apollo 1, you know, we lost 3 astronauts in that whole process before they went into space. And, you know, there is a sacrifice that we have to also consider, which is the human sacrifice. And it is not easy. It is not easy. Now, if we think about going, you know, if you think about the space station right now, we have 6 astronauts that we know when they go to the space station, they go through this transformation in their body, right? And they're there only for 6 months. Going to Mars is 9 months trip. So we do not even know what's going to happen to those bodies in a 9 months trip to Mars, right? And if you think about, you know, and then if you think about that, you know, once you arrive to Mars and you have to come back, it's about a year and a half, you know, transportation to come back to Earth. So we're already talking about 2 years, trip for a human body to be out of this Earth, this gravity. And so the body definitely is going to change. And we also have to have the technology to be able to maintain it. How are we going to maintain the body for 2 years without gravity in a vehicle that pretty much is probably going to look like the space station, right? You know, to have all that current, you know, infrastructure to be able to maintain the body. And now if we arrive to Mars, now the question is, how are we going to keep that human body, you know, also be able to live in that environment? We know right now that there is a material in Mars that causes cancer in the human body. You know, it's been identified. So if you think about it, you know, in the Martian movie, they thought about putting, you know, growing potatoes, right? And then be able to live that way. But in reality, we have to question, can we actually do that? Because now that we know that there is some material or some chemical in this soil that it can cause cancer, what is that going to happen if we, you know, grow plants, right? So there's a lot of things that we still need to work on, and there's a lot of resources that we still need to get from, you know, to be able to keep that life, go to Mars, you know, keep it alive, and then come back.